Section 2.3, Functions. Relation, domain, and range. A relation is a set of ordered pairs. Okay, ordered pairs talking about like the frequency x, comma y. The domain of a relation is the set of explanatory variable, and the range of the relation is the set of all values of the response variable. First, look at the domain. Domain is talking about all the possible values of x. So assume this is gonna be my domain, all the possible values of x. And then for the y, the range, we have this guy here, okay? All the possible values of y, that is your range. So from the x to the y. And then we could consider the domain is gonna be your input, and then your range, that will be your output here. So this is gonna be the relation. The domain we also call this is explanatory variable. And then the range, we call this is gonna be response variable. A relationship described by a table. So we do have the order pair. Okay, you could write it as an order pair. Frequency 3, 2. And then we could describe by a graph. Okay, we have a first coordinate 3, 2 here. Second one 4, 1. And then 5, 3, and then 5, 4. Okay, so the x, that will be my domain, the possible values of x. And then the y, that will be the range, the possible values of y here. And relation, you could consider this is like input and output machine. So think about it. When x equal to 3, we go into relation, go into the machine, then the output, we're gonna get y equal to 2. And that's why we do have this order pair. Okay, one more time. X, that will be your input. Go to the input-output machine, the relation, and then we're gonna get the output. And then 4 and 1 in here. Okay, and I need you guys to pay attention for the last one. When x is equal to 5, we do have a 2 outputs here. Y equal to 3 and y equal to 4. Okay, I want you guys to highlight this one. Definition. A function is a relation in which each input leads to exactly one output. Highlight this guy, exactly one output. Okay, one more time. Each input leads to exactly one output. We call this is gonna be function. For example, I do have a 4 order pairs here. And then let's write down the domain. The domain is the possible values of x. So we have a 2, 3, 4, and 5. Okay, this is gonna be the domain. And then the range, what is our output? Output will be 3, 2, 5, and 4. Okay, and you can see each value of x, they only have a one output of y. So by the definition here, a function is a relation in which each input leads to exactly one output. So we call n is a function because each x value has exactly one y value. Try this one. Write it down the domain first, and then write down the range, and then determine if this is a function. So you can see I have the domain here, I have the range. Each x value has only exactly one y value. So this is good. M is a function. Okay, this one. Decide whether the relation determines a function. Same idea, write down the domain and then write down the range. Okay, so you have a -4, 0, and 2 here. I do have a 2, -4, so I put it together. And then you could see for the -4, we do have a 2y output. Okay, so this is not a function because x value has 2y values. This is not a function. Remember the previous example right here. We have only one x, but then we have a 2 outputs here. So this is not a function either. But for this example, when -3 and 3, that's a 2 different x value. Go to the same y, that's okay. This is going to be a function. Okay, right? So this is not a function because we do have a 2y values for the same x. Okay, mapping. Relations and functions can also be expressed as a correspondence or mapping from one set to another. In the example below, the arrow from 1 to 2 indicates that the ordered pair belongs to F. Each first component is paired with exactly one second component. Okay, one more time. When we have a two different x, even they go to the same y, that's okay. This is still a function. However, when you have the same x go to two different y, then this is not a function. I want you guys highlight these two pictures and keep in mind that two different x to the same y, that's okay. But same x to go to two different y, this is not a function. Okay, domain and range. In a relation consisting of ordered pairs, the set of all values of the independent variable x is the domain. The set of all values of the dependent variable y is the range. Remember we say the relation is just like the input of x go to the y, that's the output. So that's why the input of x we gotta call independent variable. But for the y output, that is depends on what you plug in for the x. So the y here, that will be the dependent variable. Finding the domains and range of relations. Give the domain and range of the relation. Is the relation a function? First, write down the domain. All the possible values of x, right? So we have a -4, -1, 1, and 3. That will be your domain. And then the range, the possible values of y. So we have -2, 0, 2, and 5. So look at it. Each domain go to exactly one value of y here. All right? So this is going to be a function. Okay, this one. What's the domain? Domain will be here, right? The input values. The range. Is it a function? No, right? Because we have a 2 to go to 5 and go to the 6. We have the same x, but we have a 2 different y. So this is not a function. Another example. So same thing, the domain is talking about the possible values of x. And then you should see we do have the same y here. So this is a function, right? Because each x value corresponds to exactly one y value. Okay, now instead of give you guys the order pairs, I'm gonna show you the graph here. And think about it, what is the domain and range? So this is the straight line. This is a linear equation. It's gonna be keep going, right? So the possible values of x, it can be anything. So we say the domain will be from negative infinity to positive infinity. For the y, that's the same thing. Okay, this line can be keep going up. This one is gonna be keep going down, right? So the range is also all real values from negative infinity to positive infinity. Okay, how about this one, the oval? Look at the x. Look at the x here. The domain, that would be from -5 to +5. Okay, and it's gonna be equal to. So we use the bracket because it's equal to -5 and also equal to +5. One more time, the domain will be the possible values from -5 to +5. And then the range, we're gonna look at the y values here. Range from the graph is gonna be from -3 to +3. Okay, try this one. Okay, domain will be look at the x, right? So this is the parabola. It's gonna be going downward. So this guy's gonna be keep going. So the x is gonna be from negative infinity to positive infinity. And how about the range? The possible values from this graph is gonna be keep going down. So the highest point that will be from the 4 here. And then this guy, you can keep going down. So that'll be from negative infinity until +4. Okay, after we know how to find the domain and the range, we do have the one test called vertical line test. If every vertical line intersects the graph of a relation in no more than one point, then the relation is a function. Okay, if you want to see the relation is a function, you could use the vertical line test. For example, let's go back to the beginning here. Vertical line test means I could draw the line here. I have a 1 point, this is good. Draw the line here, this is good. I only have a 1 point. But this one, when I draw the vertical line here, I'm gonna intersect more than 1 point. So I know this is not a function. Okay, you could do the same thing for like those examples. Okay. Let's try. Use the vertical line test to determine if the relation is a function. So when you draw the straight line here, I intersect more than 1 point. So this is not a function. And this one, when I draw the vertical line here, I only intersect 1 point for everywhere, right? Only 1 point. So this is a function. Okay, try 2 more. Okay, this one, I only intersect 1 point, right? So this is a function. This one, when I intersect more than 1 point, so this is not a function. Got the idea, right? Okay, determine if the relation is a function and give the domain and range. So first, y equal to x squared. This is gonna be the parabola, right? It's gonna be the U shape. And then +3. So you're gonna shift 3 units upward. You should have this graph here. So we can use the vertical line test. I only intercept one point. So this is a function. Okay, so this is good. And then what is the domain? Domain, it can be all view values from negative infinity to positive infinity. And then the range, the minimum point that will be here, 1, 2, 3, starting from 3 until positive infinity. Okay, this one. Determine if the relation is a function and give the domain and range. So this is x equal to absolute value of y. So you know this is going to be the V shape. And this is absolute value of y. So the V shape is going to be like this. Right? So the domain, you could see the graph is going to be starting from here. Right? The domain. So it's from 0 to positive infinity. And then the range, that will be all of them. So it's going to be all view values from negative infinity to positive infinity. Oh, and also we need to determine if this relation is a function. So we're going to use the vertical line test. We draw the vertical line here. We're going to intercept more than one point. So this is not a function. Okay, not a function. This one, determine if the relation is a function and give the domain and range. So we do have rational expressions here. On the denominator, we say that this guy cannot be equal to 0. So x plus 2 cannot be equal to 0 means x cannot be equal to negative 2. Right? When x equal to negative 2, this guy becomes 0. So 3 divided by 0 is undefined. So we do have the asymptote. X cannot be equal to negative 2. And then you could try to plug in those points here. Okay, you're going to find it out. The graph is going to be looks like that. And then first, determine if the relation is a function. So let's use the vertical test. Draw the line here. Draw the line here. I only intercept one point. Right? So this is good. This is a function. And then the domain can be from negative infinity until it cannot be equal to negative 2, right? Since this is the asymptote. So the domain will be parenthesis negative infinity to negative 2 and then close parenthesis. And also we're gonna start here. So parenthesis negative 2 until positive infinity. Same idea for the range. The y cannot be equal to 0. Okay, so from the range, negative infinity to 0, parenthesis. Parenthesis means not equal to this value. And then starting from 0 to positive infinity. Okay, function notation. Rather than use an equation, table, graph, or words to refer a function, we name the function. We use f of x to represent the y. Okay, you could think about it. Y will be equal to f of x. For example, when I have the linear equation, y equal to 2x plus 1. I could substitute function x for the y here. So I'm going to replace the y, write it like f of x equal to 2x plus 1. And we call this as the function notation. And the notation does not mean f times x. This does not mean multiply. It is another variable name for y, okay? They do have the same thing, y equal to fx. Think of the function x just like your input and equal to output here. Plug in x to the f here. And then find it out, what did you get, and that will be output equal to your y here. So for example, if I see f of 4, we're gonna say that we want to find the function f when x equal to 4. Okay, let's try to do the example. We have a two function, f of x and g of x. And then I want you guys plug in x equal to -3 into the f and find out what did you guys get. And also find out x equal to r, plug it in. And also for the g of x, plug in r plus 2 here. Let me show you guys the first one, f of -3. So I plug in x equal to -3. Make sure you put the parenthesis because you do have the negative number. Okay, we're gonna take care of it one by one. -3 times -3, which is gonna be +9, right? +9 times negative. So -9, negative become positive. +18 plus 4. Do the math here. You're gonna get 13. Okay, plug in f. Now plug in x equal to r into the f function. So you should get this guy. Pretty straightforward, right? We paste the x with the r here. Last one. Find out what is a g of r plus 2. Okay, plug in r plus 2 here. Distribute the 3. Combine the 9 terms. You should get 3r plus 7. Okay, f of -1 for each function. So same idea, plug it in. Okay, plug in x equal to -1. Take square, you're gonna get -7. Okay, how about b? You're gonna say, hey, there's no x here, right? Remember, f of -1 means x equal to -1. Look at these 4 order pairs. Which one has x equal to -1? That will be this guy. Alright? So the output, that will be equal to 6. Try this example. Find f of -1. Okay, this one, x equal to -1, which is gonna be your domain. So it's gonna be go to the 5. So f of -1 equal to 5. This one, when x equal to -1, x, this is x equal to -1, y will be equal to 0. Finding an expression for f of x, consider an equation involving x and y. Assume that y can be expressed as a function f of x. To find an expression for f of x, use the following step. Solve the equation for y. Replace the y with the function of x. Okay, for example, assume that y is a function of x. Write the equation using function notation. Then find f of -5 and f of t. So first, we do have the equation here. We're gonna use f of x to replace the y. And then now, we're gonna plug it in, -5 here. Simplify it, you're gonna get 12. And then another one, plug in f of t here. So x equal to t. So that would be your final answer. T squared plus 2t minus 3. Okay, try the last example. So this one, we have the linear equation. So first, we try to solve for your y, okay? Find out y equal to something. After we're done, we could just replace the y with the function x. And then you could find out f of negative 5 and f of t. So first, solve for your y. You're gonna subtract the 2x for both sides. And then divide it by negative 3 for both sides. Okay, now you have the equation with y equal to. Now we're gonna replace the y with your function x. And then plug in x equal to negative 5 here. So you should get negative 16 over 3. And find out f of t. Plug it in. That's it.